We're gonna get into solving proportions, and this is at the pre-algebra level. So I'm gonna just jump right into it. Basically, a proportion is when you have one fraction equaling another fraction. Okay? So for example, I could say a half is proportional to 4 over 8. Right? This is a true proportion. Okay? Because if I was to reduce 4 over 8, I'll see that it's the same as 1/2, right? So this is a true proportion. If I had a half equaling 2/3, this is not proportional. Not proportional because it means that they are not the same proportion. All right. So it's same in terms of percentage. That's what that really means. Even though this looks like a bigger quantity than 1, it's a bigger quantity than 2, but percentage wise, they hold the same weight. That's 50%. That's 50%. So at the pre-algebra stage, you'll see a question that says, is 6/7 proportional to 12 over 14? So there's a couple ways you can do this. You can cross multiply. Here is where true cross multiplication occurs, where you're actually multiplying. You're saying things like 6 times 14 is equal to 12 times 7. Right? So what's 6 times 14? Let's see. 6 times 4 is 24. 6, 1, 6, and 2 is 8. So that's 84, and 12 times 7 is also 84. So this is a true proportion. So it'll be a true or false question, and the answer here, it's going to be true. Another way you can look at a proportion problem is that you can possibly reduce the bigger fractional part to see if it reduces into 6/7. So we can prime factorize our 12, and we can prime factorize our 14, and we'll see that we get 6 over 7. So we see that these two fractions are the same. So that's also one way of looking at it. Let's look at another example. Let's say we have 9 over 18 equals to 12 over 24. So you have a choice. You can do this big multiplication problem here, which is probably not what I will do. Okay. Unless I'm allowed to use a calculator. I don't want to be burdened with multiplying big numbers to find if fractions are proportional. But I can. But here's what I'll do. So you can try it out. You can try a calculator and see, or working out a fraction to see if they're proportional. But here's what I'll do. I'll actually prime factorize all of my digits and see if they pan out to be the same fraction. What's this? 2 times 2 times 2 times 3. Right? When you prime factor, I find prime factors of the number. So let's see what's happening here. This is 3 times 3, that's 9, check. 3 times 3 is 9, 9 times 2 is 18, check. 2 times 2 is 4, 4 times 3 is 12, check. 2 times 2 is 4, 4 times 2 is 8, 8 times 3, 24, check. All right, so I prime factor it, or you can just keep it even simpler by multiplying depending on how big the numbers are. And then I reduce to see what they have in common. So here, 9 over 18, if I reduce it as a half, and if I reduce 12 over 24, I'm left with 3 over 6. So these are not proportional. Wait a minute. What am I doing? Oh, yes, it is. Ha, just testing. We see they have a common factor of 3. So this also can be reduced. Because when I notice here, this can also be reduced to a half. So the answer to this is actually yes. Let's see if we can find one that's not proportional. So let's see. We have 18 over 27 and 36 over 81. Like I said, you can cross multiply. And if one side equals the other side, then they're proportional. If they're not equal, then they're not proportional. Or we can reduce the fractions by prime factoring each factor that is given. All right. So here we go. So prime factors of 18 are 2 times 3 and 3. 27 have 3 factors of 3. 36 is 2 factors of 3 and 2 factors of 4. And 81 is 3 factors. Yep, so sorry about that. We have 4 factors of 3 for 81. And we have 2 factors of 3 and 2 factors of 4. Of 2 for 36. Sorry about that. I was just rudely interrupted. So let's reduce to see what we have. So 18 over 27 is actually 2/3. All right. And then 36 over 81, let's see what that brings. It's actually 4/9. So here is no. So these two fractions are not proportional. So let's see another way in which proportional questions at the pre-algebra level will present itself. It'll actually present itself with a missing value. So they'll ask you to actually solve the proportion, right? Where you'll have like a missing value times another value. And there's two ways you can also look at this because you know the fraction is proportional. So that means the denominator will equal denominator, numerator will equal numerator. So the first way you can do, you can actually cross multiply. So this will be 32n equals to 8 times 20, which will actually give you an equation to solve. So you have to find the value of n, right? See how I'm working on it? I multiply the factors over here. I have 32n, so I'm solving for n. I'll have to divide by the factor 32 both sides. And let's see what we'll have when we do that division. So I have a couple options. I can prime factor 160, which will give me 16 times 10. 16 is actually 4 factors. That's a lot of work. 4 factors of 2. So here we'll have 2 times 2 times 2 times 2 times 2 times 5. And 32 is actually 5 factors of 2. All right. So I have 5 factors of 2 in my numerator. And I have another 5 factors of 2 in my denominator. So actually, if I was to divide 160 into 32, the answer is actually 5, right? So let's test it out. 32 times 5. 5 times 2 is 10. 15. 5 times 3, 15. And 1 is 16. Right. So this is actually, n is actually equal 5. So, you know, it depends on what they're asking for. So this is really saying 5 over 8 is the same as saying 20 over 32. So that's one way of looking at it, cross multiplication. And the other way you can look at this is you can actually, if you have, you know that this fraction, if you want to know if they're proportional, just reduce it in simplest form. So 20 is actually 2 times 2 times 5. 32 is actually 5 factors of 2, right? And if I reduce, I am left with, this is n over 8, and I'm left with 5 over 8. You got to make sure that whatever you left with is the same denominator. Once they're the same denominator, then it's going to be the same numerator. So n is equal to 5. So that's one way you can actually approach a problem like that. Yeah, so basically that's a proportion. I could do one more. You can see it where it's the opposite. You can find your value of n in the denominator. The principle is still the same. So you can cross multiply. All right, so we have 96 equals to 9n. Then we could divide both sides by 9. And it looks here like we will have some type of decimal. So this type of question is actually asking to round to the nearest hundredths. So here's the question here in your text. It's asking for the round to the nearest hundredths. So actually we know that some form of decimal might occur here. So let's see what that looks like. All right, so let's see. So we can find one factor of 9 in 9. And we can find 0 factors of 9 in 6. So we're actually going into our decimal phase. And we're going to bring down our 0. So we know we can actually find 6 factors of 9 in 60, which will give us 64. And our remainder here will be 6. Add another 0. And this looks like it's going to be reoccurring. So if it takes us to the nearest 100, this would be like 10.66666 to the hundredths place. Here is the hundredths place. We're doing rounding now. The number to the right of our place value digit is greater than 5. So this will actually increase with 1. So it'll be 10.67. So our value for n is actually 10.67 equals to n. So now the question is, can I reduce to find out the value of n? Well, the only way that will be possible is if your numerator is going to be 8. If you can get your numerator to be 8, then yeah, whatever is in the denominator, then they're proportional, they're equal. But as we can see that, you know, our numerator here is already 9. So there's no way we can break up the factors of 9 and turn it into an 8 to get a factor of 8 in 9. So again, if it's possible that you can see you reduce it and end up with the same denominator, then you know that the numerators are the same. But if not, cross multiplication will be your safest bet. All right, good luck.